Hello, this is section 10.2. We're going to continue on with solving our quadratics. This method is called completing the square. It's old. The old Greeks used this way back in BC times, and it leads to the quadratic formula. So this stuff is kind of neat in itself. But anyway, the first thing that I want to do is I want to remind you of something that you haven't had for a couple sections here. What if I wanted you to factor that? Well, remember there was this one type of trinomial that was called a perfect square trinomial. Do you remember those? Vaguely? All right, remember when we took this in half and then we squared it, and it ended up being that. It was a perfect square trinomial. So it always factored to that. Remember that? Keep this in mind, because when we use completing the square, we're going to force our trinomials into perfect square trinomials so we can use the square root property. Okay? So anyway, that's just a review there for you. But in any case, let's write down our steps for completing the square. We have a bunch of steps that if you do these enough, they'll just become second nature for you and you won't even have to look at the list. Okay, so the first thing is to make sure your leading coefficient is 1. All right. Next step is to make sure that your constant term is on the right side. Third one is to half the x term, square it, add it to both sides. Fourth term is to factor, and the fifth term is to solve. Okay? Completing the square. If the ancient Greeks did it back then, digging in the dirt with sticks, then we can do it with a calculator and our nice whiteboard here. So that's all there is to it. Okay, so I'll see you for the next section. No, I'm just kidding. Just kidding. Okay, I've only put 7 of these on there, and I'm going to do a fair bit of them just to let you kind of get an idea of how they run. That was a joke. All right, so I'll go back to my directions. So let's write down our first one. We have x squared minus 6x equals negative 8. Okay, so my first and second steps here are done because my leading coefficient on this one is a 1. Right? And my constant term already is on the right side. So I don't even have to do these first 2. Now we're going to get some that the constant term is not on the right side, so let's just take a look at, like that one. See how it's on the left? We just have to move it over. And then eventually we'll get into ones where the leading coefficient is not a 1. Those are a lot harder to work with. Okay? And then I'll show you how to do that. Just going to get that way up there. All right, so what's my third step? I take half of my x term, I square it, and I add it to both sides. All right, what's my x term? My x term is a 6. Okay, so what that is always the number that sits in front of just the x term, not the x squared or the constant, but the one that has just the x. I don't care so much about the sign because when I square it, it's going to turn out positive either way, whether I square a negative or a positive, so you can just disregard the sign. So I take my number, 6, I take it in half for a 3, I square it for a 9, and this is the number that I'm going to add to both sides. Okay? So I'm going to say I've got this plus 9 equals negative 8 plus 9. Whatever I do to one side, I do to the other side. Okay? Now what have I done? I have forced this side to be what? A perfect trinomial. What's half of 6? 3. 3 squared is 9. Okay, remember back up in here, that's what my perfect square trinomial was always? It always factors to that. So what I'm doing is I'm forcing it to be something that's useful for myself. Okay, since this is a negative, this is always going to, I need 2 of these, both negative. All right. Now the trick to this, because obviously this is very easy to factor at this point, right? Well, here, let me do this. X squared minus 6x plus 9. Let's just factor that, okay? We know that we have, the signs are the same. They're both going to be negative. I make my list of what makes a 9. 9 times 1, 3 times 3. I have to have a pair that adds to the middle term, 3 and 3. And I have 2 of them. Okay, so that's where I got that from. Now, when these get really messy and nasty, and they are going to be, the trick here is that the number that goes here is always this number unsquared. It's always just half of your original x term. So just keep that in mind when we need that. Right now, these are really easy to see, but they won't be. Okay, and I'll remind you. Okay, so that was my factor. So I factored my left side. I turned it into a perfect square trinomial. And now I'm solving for x. Well, negative 8 and 9 make what? 1. Now I'm back to section 10.1, aren't I? Yep. So I'm going to square root both sides. Square root of a square is itself. Square root of 1 is 1. And I'm solving for x, so I'm going to add my 3 across. So I have x is equal to plus or minus 1 plus 3. All right, well that's got to be split into 2 different problems. I'm going to take my positive 1 plus 3, gives me a 4. And my negative 1 plus 3 gives me a 2. Those are my 2 solutions. Now how do I check those? Well, I can throw them into the original. Let's just do one of them. Let's do the 4. 4 squared minus 6 times 4 is supposed to equal negative 8. I'm going back to my original equation and I'm putting a 4 in here. We're going to see if this works. 16 minus 24 is equal to negative 8. 16 minus 24 is negative 8. So that one works, and so would the 2. Another way to do it is to add my 8 across. So I would have my x squared minus 6x plus 8. And I would check it with my calculator to see where it crosses the x-axis. All right, we just learned that last time. So we have multiple ways of checking these. It's really your choice. And just like before, you're not going to be able to check all these. You're not going to be able to find the answers through this. You can check your answers through this, but you can't find the answers through this. This one you can find the answers, right? We're saying that it's 4 and 2, so we'll go into the table. We'll go down and see if 4 and 2 are indeed the zeros. Yep, 2, 0, and 4, 0. And it looks like that's where it's crossing, 2 and 4. So you have multiple ways of checking these, okay? So here you want to do 4 and 2. Fantastic. Okay? So in a nutshell, that's completing the square. You just follow these steps, and they're all done the same. Now, is this going to get nasty, messy in through here? Yeah, it is, because you've got radicals. They're not going to all be perfect squares. You're going to have fractional stuff, so they get pretty hairy as we go along. Okay? So, let's see what we want to do here. I think we'll work on number 2 is the same, and when you drag that across, it's a 4. And that's a perfect square, so that one's fairly straightforward, but this one's not. This one's not as straightforward. So I think we should do, I'm going to do this one. I've kind of looked at the ones that I want to do for sure. I want to do that one, and then there's 2 more that I want to do. All right, so let's begin, shall we? We've got x squared plus x minus 1 equals 0. Okay, my first step was that the coefficient in the front has to be a 1. It is. Okay? My second step said that my constant term needed to be on the right side. So it is not, so I will add 1 across to both sides. just to move it over there. All right, now what I'm doing is I'm taking my x term. What is my x term? It's a 1 here, right? I'm taking 1. What did I have to do? I had to take it in half. Then I had to square it. So that's 1/4, right? 1/2 times 1/2 is 1 times 1 is 1, and 2 times 2 is 4. So this is the number that I'm going to be adding to both sides. And this number here, this 1/2, is what goes inside for the factoring. Okay? So let's start by adding it to both sides. We've got x squared plus x plus 1/4 is equal to 1 plus 1/4. See how nasty these can start to get? Okay, so that was my, well, I don't know what step that was, 3rd or 4th, can't remember the numbers. The next step is to factor. I have forced this into a perfect square trinomial. Okay, I have a positive middle term, so I'm going to have x plus something squared. Remember, it's always the unsquared version of half of your term, so this is 1/2 here. That comes in handy, because this is a lot harder to factor than the first one that we did. So remember, it's always just half of this term goes here. All right, and here we have 1 and 1/4, so we have 1 is 4/4 plus 1/4 gives 5/4. What makes this nasty are the fractions. Okay, now I'm solving for x. Do you see how I've got my perfect setup for a square root property? That's the key. So the first thing that you want to do is you want to force it into a perfect square trinomial so that it can become something that looks like this for the square root property. So we will take the square root of both sides. Square root of a square is itself. We're going to take the positive and negative values of 5/4. Now we have to abide by all of our radical rules that we have learned in the previous chapter. We cannot have a perfect square underneath there, and we cannot have a radical in the denominator. So we've got some issues going on here. So let's just pull this off to the side and just start working with it over here. I can split this according to my quotient rule, right? Each one gets its own radical sign. Square root of 5, there's not much that I can do with that, but the square root of 4 is a solid 2. Okay? This does not have a radical, or excuse me, a perfect square underneath there, so this isn't one's finished, and I took the radical in the denominator away. Okay, I didn't have to rationalize or anything. So now I have x plus 1/2 is equal to plus or minus radical 5/2. Okay, that's what this is. Now I have to solve for x, so I'm going to subtract my 1/2 across. So this is gone. I'm going to go up here. So I have x is equal to plus or minus radical 5/2 minus 1/2. Okay. Now my math lab is going to want that into one fraction. It doesn't want it split up like that. So this is the same thing as negative 1/2 plus or minus radical 5/2. Not that that's terribly important, but we usually want to put the numbers in front of the radicals. And since we have a common denominator, we can go ahead and add those for a negative 1 plus or minus radical 5/2. Okay, these have a common denominator, so I'm just going to add my tops. So my two answers would then be negative 1 plus radical 5/2, comma, negative 1 minus radical 5/2. Now how do I check that? Well, I'm going to have to put it into my y equals, and I'm going to have to calculate these out using that calculation button looking for the zeros. I'll have to find my decimal equivalencies on these, and then I'll have to calculate and see if they're the same. Okay? So that's what you're going to have to do if you want to check these. But I'm not going to check this in here. But these are the two that my math lab wants. All right? And then what's another one that I wanted to do? For sure 21. Okay, so for sure this one I want to do because look at that leading coefficient. It's not a 1. Okay. So we better get a nice new screen for you, just for you, because it's all about you. So let's write down our original problem. All right, step 1 says this has to be a 1. How do I make that into a 1? Well, if I would divide every single term by 4, then that's okay. As long as I do the same thing to all terms, I'm good to go, right? I can always do that, but it has to be everything. It can't just be certain things. Every single term gets divided by 4. 4 divided by 4 is just x squared. Do you see how I turned that into a 1? 4 divided by 4 minus 3/4 ic equals 0 divided by 4 is 0. Add my 3/4 across because I have to have that constant term over there. Okay? Now I'm back in the same situation I was on that other problem. Okay, I'm taking half of 1, squaring it, and adding it to both sides. This is actually turning out to not be such a bad problem. Kind of like it. So we have x squared plus x half. Okay, my x coefficient is 1. Take it in half, square it. We got a quarter. Okay, plus 1/4 is 3/4 plus 1/4. This will turn out to be really easy. We have x, this is a positive, so this is a positive, plus 1/2 is equal to 3/4 and 1/4, or 4/4, and 4/4 is 1. Right? Now I've got it set up for the square root. And I can take that out. Square root of 1 is 1. We're back to these really easy ones with the radical being a perfect square. And I subtract my half across. So I have -1/2 plus or minus 1. Well, that's going to split into -1/2 minus 1 and -1/2 plus 1. So this would be -3/2, and this is 1/2. Okay? So that one, that's how those go. Now these aren't going to always be as nice and neat as these because this turned out to be a nice perfect square. But if it's not, then you're just going to go back to the ones where you're breaking apart your radicals and you're simplifying according to all your radical rules and all that stuff. Okay? All right, and the last one that I want to do is number 27, which is what? Huh. Well, I don't see it on here. Well, we'll just do this one then, because we're going to look for the imaginary solutions. All right. I don't know what happened. I wrote down number 27, but there isn't a number 27, so all right. Then we shall do this one. It's going to get hairy. All right, so what we want to do in the end is we have to write it in terms of a plus bi. My first step says that I have to get rid of, this 3. So I will divide each term by 3. And this is really looking ugly, isn't it? 3 divided by 3 is, you know what, I'm going to change these to x's. I'll change it back. I can't stand working with r's. Then I've got 4/3 x plus 5/3 is equal to 0. So that's my first step, is I got to get rid of that leading coefficient, turn it into a 1. Then I've got to get this thing on the other side, so I would subtract 5/3 from both sides. So now I have x squared plus, plus 4/3 x is equal to a -5/3. All right. What's my x term? It's 4/3. I want that in half. Okay? Multiply that by a half is equal to 4/6. Square it is equal to 16/36. That's what I'm adding to both sides, 16/36. So now I have x squared plus 4/3 x plus 16/36 is equal to negative 5/3 plus 16/36. Right? Yikes. I'm adding this magic number to both sides because I'm forcing this one here to be a perfect square trinomial. All right. So let's use the calculator for this. We have a negative 5/3 plus 16/36. Math, enter, enter. All right, so we have a negative 11/9 on that side. We could have done it by hand as well, but not necessary. All right, I have a plus here, so I've got a plus here. Now this is going to be a nasty thing to factor. So we go back to that little trick that I said. Remember I said I always have to take this particular one in half. Well, this one in half was 4/6, which is 2/3. You can also do it on the calculator. You can take the 4/3 divided by 2. Math, enter, enter. So we have 2/3. So that's what this is going to go in here. Okay, 4/6 or 2/3. Doesn't really matter which one. It'll get reduced down either way. Okay? So now I factor. No, I just factored. That is factored. Now I square root. See how I'm getting some imaginary stuff in here? All right, so now I've got x plus 2/3 on this side is equal to plus or minus radical negative 11/9. All right, so we better clean that baby up, huh? Let's go over here and do it. If we have negative 11/9, we can split that up into negative 1 times 11 and 9. Okay, I can split my division and I can also split my multiplication. So that would equal I, roots of 11. Okay, that's this piece of it, that's the I, over 3. Right? Isn't that what that is? What that is? I do believe it is. So now we have x plus 2/3 is equal to plus or minus I roots of 11 over 3. Now I'm solving for x, so I'm going to subtract my 2/3 across. Minus 2/3. I'm going to go here. So now I have x is equal to a negative 2/3 plus or minus I roots of 11 over 3. And that should be finished because I've got my A, I've got my B, I've got nothing to do underneath my radical. Square root of 11 can't be finished. So here we have negative 2/3 plus I roots of 11 over 3, comma, negative 2/3 minus I roots of 11 over 3. Okay, and I'm going to be lazy and I'm not going to check it. So that's completing the square. Not my most favorite method, but definitely a method. So this is terribly important for college algebra. You'll see this again in college algebra, and more than likely you'll be doing college algebra in class. So you'll have to be doing stuff on paper, and then they'll force you to use the appropriate method. So it's very important to learn how to do that. All right, so that's it for completing the square, and I will see you for the quadratic formula on 10.3. See you then.